Cincinnati tattoos. Had a lot of requests and seen a lot of things on YouTube, you know, about coils and people trying to make their own coils and questions about winding coils. Why do they get jumbled up at the tops and bottoms and blah blah blah. You know, just different people trying to figure things out. So I thought that I would throw another stone into the pond of information that's already out there. But this is a video simply to show you some tips on how to wind coils. There's a lot of ways to do it. There's a few ways to do it right, and you know, a couple ways to do it really good. Now, mine isn't the only way to do it. It's the way I do it. So that being said, I'm going to go over with you from how I get the raw piece of round iron, how I measure it, how I turn it on the lathe, how I drill out insulating washers, how I insulate the cores, how I wind the cores, how I test them after I wire the cores. And I'll go over almost all that stuff with you in this video, and hopefully by the end of it you'll be able to figure out how to wind them yourself, or if you still buy them, how to determine if it's a good set of coils by the way that they're wound. There's a few ways you can determine that without, you know, taking the coils apart necessarily. You can figure out if they're good coils. So that being said, we'll go ahead and get started. There'll be some still images in the video, like all my videos. There'll be some stills, there'll be some video, there'll be some, you know, captions throughout the video. But at any rate, all right, let's go. If you've ever taken the time to measure a coil core beyond its overall height, we're using in this example 1.25 inch coil core, 1.25 inch. You'll realize that from top to bottom, obviously this is 1.25 inches. However, the maximum amount of area on this core that you can wind once you put 2 insulating washers on here should be right at 1 inch. Okay? So that's important, because when you're going to measure your coil core to turn it in the lathe, you've got 2 insulating washers, and they take up combined together 0.25 of an inch. Okay, so 0.12, you know, thickness is it's about 0.25 anyway. So that leaves you 0.25 minus, you know, 1.25 minus 1/4 inch for the washers leaves you a 1 inch windable area. That's important when you go to cut your coil cores, your round iron for the coil cores, like I have here. You want to take those numbers into consideration. You don't want to just measure up, you know, 1.25 inches from the end and start turning. What I do is I take my caliper and I measure up from the bottom of the round stock. I measure up like about 1 inch, like 1.12 toward the top of the coil core. I'm going to show you right now. Let me turn this lathe on and mark, make my mark real quick. Okay, this mark is going to be how far up the bottom of the, you know, it's where my insulating washer is going to rest. So this mark and below is where the insulating washer is going to rest. This mark and above is where the top of my coil core is going to be. So if I've got 1.12 from here, I know by the time I put, you know, 0.12 down here at the bottom to cover the the width of my insulating washer, I know that leaves me 0.12, 0.12. That leaves me a 1-inch windable area within this coil core top. So I can actually make my cut with the bandsaw or the chop saw or whatever up here, and make my total coil core length 1.125, and leaving 0.12 here, and the middle leaves me a 1-inch windable area. So that might sound confusing, but all you're striving to do is, and a 1-inch windable area in the middle, okay? And that's what you're wanting to get done. Okay, so here I have a piece of just round stock, 1/4 inch, 1/2 inch round stock. I can't even think today. 1/2 inch round stock, and I'm going to turn it down to a 3/8 coil core, okay? And we're going to wind up with coil core, okay? So what I do, now I've got my mark on here. I don't know if you have a lathe or not. If you do, great. This isn't a machine shop video, but I'm just going to show you real quick how this starts from the round iron. And matter of fact, you can buy this at Home Depot. This is like $6 or $10, I forget, for 10-foot section. Make a lot of coil cores out of a 10-foot section of round iron. Okay, when you think about what they charge you just for coil cores, which is about $6 a set if you buy them on eBay or wherever you buy them from, they're $6 a set. If you buy, and get them shipped to you, that's pretty expensive when you can buy just the round iron and make your own coil cores if you got a lathe. This is just a Harbor Freight lathe that I made a few modifications on, but here we go. I'm gonna stop rambling, and I'm gonna go ahead and got my safety glasses, put these on. I'm gonna go ahead and get this going. This first cut I'm going to make just a little slow to. My first bite's just going to be a little thin bite. A little drop of oil. But you see how this process is. It goes from ugly old round stock to nice smooth coil cores. And now make a little bigger bite on here. Speed it up a little bit. These nice long swirlies, that's what I want to see. Okay, trying to get 125-inch coils. Okay. Now let me zero my caliper out. Okay, this first coil core, the height on it is 1276, right? So I'm just going to put it on a little belt sander here and take a little bit off the bottom. 9.5, just a little bit more. Next thing I'm going to do is, you know, we've got the coil cores. We need to get a hole drilled in here, and we need to get it tapped with threads. 8/32, American 8/32. There's a difference between 8/32 from China and the difference between 8/32 from America. American screws never seem to fit in 8/32 Chinese hole. I don't know what it is. They're too tight. So anyway, okay, I've got a coil core here in the vise. All I'm going to do is walk over, grab my hammer, I'm going to put my little punch. And this just allows me to start the drill bit in there without it walking, you know, all over the bottom of the coil core, so I can drill, you know, pretty much in the center. So all it is, let the camera focus for a minute, it just puts a little tap, a little dent right there in the coil core so that my drill bit starts in that hole. Okay, it doesn't walk all over and, you know, not drill into the center. Okay. Same thing on this one. Oh, you fucker. Same. It's same. Okay. Put my hammer away. Now, so here's my good old drill press. I'm gonna get all this plugged in and get it lined up. Let me put this camera in something fairly secure. Now you guys, you know, you may not even make your own coil cores. You may buy coil cores. And for those fellas, well, you can watch me, I mean, you can still watch the beginning of the video, but, you know, at least you understand why quality coil cores cost what they cost, and why you can buy shitty ass $5 coils. Okay, there's time that goes into making these and making them right. You know, I don't. Okay, I get that secured down in my. I'm going to secure this camera. Give me 1 second. All right. Now, in my drill bit, in my drill press chuck, I've got a drill bit that's, it's 9/64. That comes, that allows me to tap down into the center of this core, and then I'll tap it with a. There's two different taps that I'll use. One, I'll use the self-starting tap, and I'll show you those here in a minute. But let me let this camera see if it'll get to focus on this. Maybe, baby. We'll see. Put the flash on, maybe. Okay, so you can see what we've got on the top of this coil core. Okay, there's the divot that I made. And, okay, I'm going to go ahead and secure my camera, and we'll drill this coil. Okay, if you look at the bottom of a coil, you're going to see the insulating washer. See if we can get this to focus. Okay, there's a start wind and an end wind. The start wind is always closest to the coil core. So basically there's two holes in the bottom of your insulating washer. Okay, all we're going to do is drill out two holes, one close to the center, or one close to the edge of the inner hole, and one close to the edge of the outer edge of the washer, and one close to the inner edge of the insulating washer. First, I'm doing the inner. The first hole is the start wind hole. and it goes close. It goes right up along the edge of the inner hole of the insulating washer. Your insulating washers can be made out of anything that's non-conductive. You know, buttons, cork, whatever, wood. In this case, it's plastic. Two holes directly across from each other. Okay. Kind of make sure there's no burrs on them. Okay. And I'll put those, I'll scuff these here on top of the belt sander real quick. That just smooths them out so there's no bores, or no burrs, no bores. We don't want bores on them either. It's a whole different video. Okay. Okay, 2 insulating washers for the bottom, 2 insulating washers for the top. Okay, 2 insulating washers for the top, or 2 insulating washers for the bottom, 2 insulating washers for the top. Coil cores. A couple ways you can do this. You can finish these, dip them in hot oil if you want. Okay, this is insulating tape. This is one thing I use right at the core. Need to have this. Okay, put your one little twist of it on there. If you can get it right, unlike me today. Okay, there we go. Okay, insulating washer goes on top, insulating washer, bottom insulating washer. Okay, same on this one. Nice, smooth, as little bit of wrinkle in there as you can possibly manage. Okay. 2 coil cores. Okay. Now, there's other ways you can do this. I'm going to show you this way right here. Let me find something real quick, hang on. Okay, let me show you this way here. It's with crazy glue. It's just fine. Okay. Take our top, slide it up on there. Put your little crazy glue. Just a few drops, all it takes. Spin it around on there. Okay. Same with the other one. Put your top on. Don't blow your top. Couple drops of crazy glue in there. Okay, spread it around. Same there. Just let it sit. Let it dry. Okay. Let that dry. Okay, we'll come back to it. We started with round stock, turned it on the lathe, got 2 coil cores, tapped them, drill pressed them, tapped them, wrapped them with insulating tape, drilled out insulating washers, put them on there. Now I'm going to show you what I use to wind coils. Okay, I made this. You can buy something that's a whole lot less durable, a whole lot slower, for a whole lot more money. Or you can look and see what I have and make something, some sort of variation of it if you want. There's a million ways to wind coils, the actual winding device itself. I'm going to show you mine, okay? Windshield wiper motor. This tape here just so there's no metal exposed to knock any enamel off my copper wire, that's all. But what I did is I drilled to 8/32. I tapped this shaft of this windshield wiper motor and I screwed some 8/32 all thread in there. And then I JB welded it in just so it doesn't come out. Okay? So this is 8/32 all thread out the bottom here. And then I sell these foot pedals, all different things. This is a Texas Chainsaw Massacre foot pedal. Okay? Push the foot pedal. See that? We're working. Car battery, yay. 4,000 foot spool of 24 gauge copper wire. Okay? It's nothing fancy, but it's mine. I made this shit. And that's what tattooing and tattoo machine building and coil winding and all this stuff's about. You know, it's about having a good time, making quality stuff that works, and understanding why what you have works or doesn't work. You know, step on my pedal, windshield wiper motor. That's $7 is rolling. You can make something like that, or you can buy something like this from eBay for $80. And all it is a 12 volt motor that hooks to your power supply with a variable speed. However, once you bolt something like this to the counter, depending on how much tension you put as you wind your coils, it drags on this motor, and it's just not going to last very fucking long, man. I won't say where I bought that, but I've got it. Don't recommend it, especially when you just go to the junkyard and get you a windshield wiper motor off an old Ford. That motherfucker is going to go for the next 20 years, man. Hey, this tool I use here, this is I've been asked a lot of times what this is. All it is a tool that comes when you buy a solder gun. It's a plastic tool that comes in that package. Whenever you're winding coils, you want to make sure that you use all plastic to touch the wire with. Nothing metal to get you might, compromise the enamel coating over it. I wrap my cores with Kapton tape, but I also use an orange tinted sealer. This right here is used in the automotive industry when you build starters and alternators and doing electrical. It's a aerosol spray that is an insulator and a sealer, and it's really good. It's got a tacky. It starts out tacky and then it dries, and I use this against the core itself after it's wrapped with Kapton tape. So let's spray. Okay. What I do now is I usually just take a little piece of, if you're going to decorate the coils out, you'll print out some kind of imagery or something like that. But if you're not putting imagery on the coil, you're just going to wrap it, then I'll take a piece of electric tape and I'll pull it real tight along the bottom just to make sure everything stays real secure in there, even though I've got that spray on the very bottom. Okay, we'll do that. Pull that real tight. I'm going to cut a piece of clear shrink tube. You don't have to put this clear shrink tube over. You can just wrap them all in electric tape if you want or whatever, but this just allows me to have a nice protective layer over the coil core itself. Just slide this on here. Put my heat gun on it. Maybe. Ooh, it's hot. Hot, 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 hot. Okay. Now, we've got us a nice solid coil core, nice tight winds, and even if this cover is on, you can tell if the winds are good. All you have to do is look at at an angle in the light and see the casing that was put over the coil. If it's jumbled up, I'll give you an example. Say like this one here. Well, you can look at the casing and see that coil isn't smooth, wound tight inside. It's got some jumbling, okay? Compared to one like this that we just wound, it's nice and smooth. Just look at, whenever you buy a set of coils, look at them in the light, whatever kind of cover they put on them. Look at them in the light at an angle and see how smooth the casing is. Okay, a lot of times the import coils, they'll put a hard piece of cardboard around them now to prevent you from doing that, but even this, though it's jumbled, I guarantee this coil will work with no problem. This thing here, I put this on any machine I got and use it any day of the week. But aesthetically, this is smooth and tight.